Hi, I'm Mike, and I'm going to give a bit of a brief presentation on test-driven development here, why it's a good idea, why it's so important, and getting even more important in software development these days. And then I'll show you practically how you can get started with test-driven development. So just give a very, very brief intro. I'm the CEO of Ustad Mobile. We are a UAE-based edtech company. We build different education apps specifically designed for environments where connectivity can be limited and settings like that. I personally have about 20 years of software development experience, and I was lucky enough to spend 7 of those years working in Afghanistan. So, with that, I will get straight into why is test-driven development really so important these days. One of the first issues is that there is a huge combination of devices and browsers out there, and a huge combination of different scenarios, which make manual testing at best extremely labor intensive and prone to failure, and often just practically impossible. How do you know that the screen that you have that's perfectly happy on Android 8 won't get really upset on Android 5 or Android 10? That's a problem. And how do you know that some component of that, isn't going to have a problem after you make a small change somewhere else? Software projects, specifically apps, as they're getting more complicated these days, what seems like a small change in one place could actually have an effect in another place. Who's going to go and do all this testing, manually for you after every time you make a change? Alrighty. And also we have a situation these days where libraries are being updated very frequently. So, Google Jetpack libraries are, often updated every 2 weeks, which are core, components of most Android apps. How do you know that one of those updates didn't just go and break something? Yeah, it compiles, fine. But how do you know that the behavior is working and that everything is still cooperating? So again, you're stuck with you have a choice between automated test-driven development, where testing is automated, or manual testing, which is at the speed of change, often very difficult to do. Then you have a quality assurance element to it. Automated testing is very good at catching most errors reliably, without human error, which can often creep into things. People might tap something and not notice something's missing from the screen. If an automated test is told to check for something on the screen, it will always check that, and it will always fail if the expected result is not on the screen. And test-driven development is used to maintain the quality and speed of development. Quality, I think that's apparent. Testing, adding in tests, clearly you would see the quality benefit to that. But a lot of people think that testing is going to slow you down. And initially, it might seem that way. However, when you don't have automated tests, and all of a sudden every change requires a lot of manual testing, then pretty soon your development is going to get slowed down because you don't have the tests, not because you wrote them. So testing helps maintain a fast cycle of development without regressions and breaking stuff that was working before as far as possible. So how do we do testing? What is it really? Well, testing is the idea that you write tests for your own code, specifying inputs, outputs, and expected results. And the best way to start thinking about how am I going to test this is to go back to the testing pyramid. And at the top of the pyramid is a user interface test. So these are tests that are run on, in the case of mobile devices, like actual devices or emulators. In the case of web applications, they run in actual browsers. And these are we call high fidelity, they an accurate simulation, and they can be end to end. So they can basically simulate an entire user journey on a certain screen or a whole set of screens. But those tests actually do take time to run, because it takes time to click from one thing to another, even if the test software is doing that automatically. So we want to have tests that are faster to run, and speed of execution is important to maintaining speed of development. So at the bottom of the testing pyramid, we have what we call unit tests, and normally you can say something's a unit test where it's just testing normally what's inside one file, what's inside one class, and we'll use a process called mocking to simulate any input or output which is external to that file, right? So then unit tests are fast, small things that we write to say, okay, this class does what it's supposed to do. If this class gets this input, it will give us the output that we are looking for. Right, so integration tests are when we take two or more units and put them together to integrate them. So the example I'm going to show is looking at one of these screens that asks you how old you are. Okay, so we have a screen that a presenter, let's say, which decides what screen the user should go to next, and then we'll have another class which says, okay, based on the date of birth of the that they have entered, or the date, is this person a child or not? So each of those would have its own unit test, and then we'd have an integration test. And then finally, we would put in a user interface test. On Android, this is typically done using Espresso or one of the aftermarket add-ons like Caspresso or Cacao and things like this. In web browsers, this is browser-based stuff. It's often done with Appium. Angular has a tool called Protractor. So every serious framework these days has proper testing in place, and this was not the case just a few years ago. Android Studio didn't even used to really support running unit tests properly, and now every Android library has testing support, which you will normally see in their documentation. So, how do we do testing? What is the definition? How can you say, yes, I am following test-driven development? And it really comes down to writing the test first. And you let it fail. Because, of course, if you write a test, which tests code that, hasn't really been written yet, you only have the signature of the method, it's going to fail. And that's fine. And you normally have a format of like, given some condition, some sort of starting point, when something happens, some sort of action happens, then you can make some assertions about what result you get. So you can actually go from your documented software specifications, like that specify what the software should do in certain situations, and then write the tests according to that. All right, so what I have here is a pretty uh, boring, empty-ish Android Studio project here, where what I'm going to do is show how we can apply test-driven development practically. So basically there are three activities here. So there's a main activity where the user would enter his or her date of birth. Okay. And then there is, an activity that would say, hey, you're an adult, or hey, you are a child. That's basically it. And then there is some logic here. Now, I like to separate out the logic and, the Android view implementation, and that's going to help make the test-driven development a lot easier and faster to run, because we want a unit test that we can run without needing the Android emulator. Right. So we'll start at the top of the testing hierarchy. So we will start with the UI test here, and what this does is it's going to actually say, okay, start the activity. This is Espresso, so this is how Android does UI testing. So we're going to say, okay, find the date picker and set the date. Now click on the next button, and then we're going to assert that once we've done that, we should see something that says you are a child being displayed. Okay, and then basically the same again, but different for the adult. So we're saying, okay, if they're born in 1995, it should recognize them as an adult. And to do this in a test-driven way, what we actually do is we write the test first, even though it will fail because it hasn't the logic hasn't been written yet. Okay, so I wanted to show you this running on the Android emulator. Unfortunately, as we know, the Android emulator, it loves to eat memory and processing power, and it doesn't want to have that at the same time as I'm screen recording. So I did run this. If you run this, and I can give a link to the repository, you would see that it would go through these steps, and it will fail because it will say, hey, I didn't find the result at the end. Okay, so now we have a failing UI test, but I want to actually add the logic here. So there's a very basic piece of logic here, which is just to check the date of birth. So what I'll do is I'll have a unit test, and we'll use something called mocking here. So this is where we don't have the real view, we don't have real files from outside this just presenter class. The purpose of this is only to test the presenter class. So what we will do here is we will create a mock of the view, then use that mock to create a presenter object, and then we'll call the handle click next method, and then we will verify that the presenter has called the method that it is supposed to call. So when I run this first without the implementation, it is going to fail. That's test-driven development. For you, you write the test first, and then you add the implementation. So let's try running that, and we'll see what happens. All right, so now we see it failed because there is no implementation here. So this is what we wanted. It said that we wanted this this method to be invoked, but it was not invoked, and it said there was no interactions with this mock. Okay, so what I can do now is I will actually go and uncomment the real implementation, and then I'll run it again, and we should see that now that there is an implementation, it should pass. All right, and now we see that it has passed. It has checked it in less than half a second. We can test the logic, so we can see that having nice, fast, small unit tests really can help actually speed up your development, not slow it down. So now I don't have to bother, running this only to, starting all of the Android emulator, only to find that, I've made some silly mistake in an if statement. So now we can go on to actually checking out the UI test. So now I want to see, okay, does this really work for the user? So then that's where I'm going to go to my UI test here that we saw earlier. Now that we know the logic is working, we have a more chance of this test actually passing. So what I will do is I will go and say, okay, let's have the logic implemented here. So here we see it, and then I will have to start an emulator and just go to the test and click to run it on the emulator, and it will run. So I'm just gonna pause this and run it so that it doesn't mess up the video recording. All right, and now I just ran these on the emulator. You see, it does take a lot longer. It's 4 seconds as opposed to 200 milliseconds, and those times will increase when you're looking at using an actual, a real app. However, it's still a lot faster many times than actually manually running through your app and opening it and getting it to the right screen and having the scenario in place. Because with testing, you can put the scenario in place, with code that, takes, some, milliseconds to run to get the screen to the right place. It will go directly to where you want it to be. So even the UI tests, which are the slowest tests, can still actually be faster, and help you run through, the code a lot quicker, and, and then you'll wind up hopefully with code that has less issues in it, particularly when you write it in a test-driven way. So one of those ways, as we see here, is to have interfaces have your view as an interface, so that you can isolate logic and test it independently. There is a lot of stuff that goes into architecting test-driven architectures. Particularly, I'd advise, although it's there's limited time here and it's outside of scope, I'd look at dependency injection, because when you start getting serious code, classes start needing other classes, and what you need is a way that it's easy in a test environment to give it a mock, and then in the real environment to give it the real instance of a particular class. So what I hope I've shown here is that testing is your friend, that it can not only help you improve the quality of the software that you are making, it can also actually help in many ways accelerate development, that it solves a lot of the most pressing challenges when we're looking at the speed of library releases. We're looking at the speed in which devices change, new versions of Android, iOS, and browsers keep coming out, and people keep on using older ones. So it gives us really a practical way that we can ship quickly and ship with some confidence. Testing also opens the gateway to continuous integration, where you can connect your GitHub and a server to actually automatically build and test a version of the app every time you make a commit to GitHub. It's also particularly helpful in a team because make sure that nobody breaks anybody else's tests. So I hope that's given you some useful introduction, and encourage everybody watching this to go and try test-driven development, make it the way to do things, and thank you for checking this out, and I'll be happy to answer comments and questions on CodeWeekend's Facebook page or any other channels that the organizers have. Thank you, and have a safe and peaceful start to 2021.